Linear inequalities and systems of inequalities review. So let's review what the symbols mean. So the name, the first one I have, is a less than. So this is what the symbol looks like, y less than. And so when you have a less than, the line type is going to be a dashed line, and the shade direction is below the line, and your solution location is in the shaded area only. The points on the boundary line do not count as solutions for less thans. For the next one, less than or equal to, your line type is solid. Your shade direction is still below the line because it's still a less than. But now your solution location is the shade and on the boundary line because the line is now solid, which graphically represents solutions. And the reason why it's a solution is because of this equal to symbol here underneath. So greater thans are similar. Greater than and strictly greater than is a dashed line. This time you're going to shade above the line because you want numbers greater than the boundary. And then the solution location again is the shade only. If it does not have equal to, you cannot be on the line for a solution. And then the last one, greater than or equal to, is a solid line because of the equal to. You are still shading above because it's still greater than. And your solution location is the shade, and it's also on the line. So for single inequalities, your solutions are going to be here. For systems of inequalities, so a system of inequalities is two or more inequalities working together. And so for a coordinate to be a solution to a system, the values of x and y has to be solutions to all inequalities in the system. So it either has to be in the overlapping shaded area, or you can plug in the coordinate and make sure it's true for both. So for number one, checking solutions to linear inequalities. So is the ordered pair 1, 2 a solution to the inequality y greater than x minus 3? So you could take the time to graph this. However, it is going to be faster if we just take this value of x and this value of y, substitute those in, and see if we get something that's true. So y is a 2, so 2 greater than, x is a 1 minus 3. Then we're going to simplify and see if this is really true. So is 2 greater than 1 minus 3 makes negative 2? Well, yes, 2 is greater than negative 2. So because that was true, that means that yes, the coordinate 1, 2 is a solution. So for single inequalities, we just have to substitute it one time and see if it's true or false. If it's true, we get a solution. If it's false, it is not a solution. So for a system of inequalities, it's the same idea. So number 2, is this coordinate a solution to the system? Well, we're going to take x and y and sub it into both of the inequalities. But remember, we have to be solutions to all of the inequalities, which basically means you have to be true for both. You cannot just have one as true and say, yes, it's a solution. So you do need to check both of them. So pause the video and decide if this coordinate is a solution to the system or not. So for example 2, you should have come up with, yes, this is a solution. Because if you substitute this coordinate into the first inequality, you get a true statement, 17 greater than 11. And if you plug this into the second inequality, you also get a true statement, 8 greater than or equal to 7. If one of these had been false, then that would mean that it is not a solution. So if you have false anywhere, it is not a solution. Let's look at graphing. So graph the solution set for the linear inequality y less than or equal to 1/2 x minus 3 on the coordinate below, then determine if the given coordinates are solutions or not. So we have to make sure that what we are given is in slope-intercept form, which we're given y less than or equal to 1/2 x minus 3, which is in slope-intercept form, so we're okay to go ahead and graph. So my slope is 1/2, my y-intercept is negative 3. So start with your y-intercept at negative 3, then use your slope up 1, right 2 to get your boundary line. Up 1, right 2, plot a point, and keep doing this process over and over again. Or down 1 and left 2 also works as well. Now for the boundary line itself, that's where this symbol here comes in. So for the less than or equal to, it's going to be a solid line because it's equal to. So we're going to connect these guys with a solid line. And because it's a less than, we're going to shade below. So everything below my line here is the set of your solutions. Okay. Now let's check and see if these are solutions or not. So letter A is 2, -1. So 2, -1. So here's A. And that is out of the shaded area, so it is definitely not a solution. Letter B, -2, -5, falls directly in the shade, so yes, this is a clear solution. 4, -1 is directly on the boundary line, so those are the ones you need to be careful with. So because this is solid, it's a yes. Solid lines are solutions. And then -1, 1 is another point that is clearly out of the shade, so no, it's not a solution. So for example 4, we're going to graph the solution set of the system of inequalities. And so now we're graphing two inequalities on the same grid. The first one is set up for you, ready to graph. The second one, you need to isolate the y value first before you can graph it. So let's go ahead and do that one together. So 2x plus y greater than or equal to 1. So to graph this, I need to get y by itself. So I'm going to have to subtract 2x from both sides. So we end up with y greater than or equal to -2x plus 1. So now this is ready to be graphed on the grid. So go ahead and graph the first one, y less than 2x minus 3, and graph the second one on the grid. Pause the video and try to graph it. Here's what you should have had for your graph. The purple one is the top inequality, my red one is the bottom inequality, and the yellow is the solution area for the system. Now, yes, there's also shading over here and here, but because this is not where they overlap, I didn't include it in my graph because the solution area is only the part of the shade where the two shades are overlapping each other. The red shade is this way, and the purple shade is this way. And so that yellow spot is the only place where those two shades overlap. Now let's check and see if the coordinates below are solutions. So pause the video and try to decide if A through F are solutions. And here's what you should have had for your answers. So the ones I want to talk about is letter B. So 2, 1 is in fact in the shade, but the problem is it's on a dashed boundary line, so that's a no for a solution. You're not allowed to be on dashed lines at all for solutions. Secondly, 1, -1, or sorry, 1, 1 is out of the shade. 1, -1 is this one here on the intersection point of these two boundary lines themselves. Now again, yes, one of them is solid, but because the other one is dashed, that's what messes this up, which is why it's not a solution. And then 0, 1 is also not a solution. Yes, he's on a dashed line, but he's not on the boundary of the shaded portion here. So that's why this one's not a solution there. Now let's work the other way. Now I'm giving you the inequality. You're going to turn around and give me the actual inequality algebraic equation for it that represents this solution. And so the easiest way to write an inequality is in slope-intercept form. The only difference is instead of an equal sign here, it's going to be either a less than, a greater than, a less than or equal to, or a greater than or equal to because of the shade. So I still need to identify M and B. So B is always the simpler one to identify. So this guy right here is the value of B at a 1. Now that's also a nice good point to help you with slope. And so I'm going to go ahead and write that coordinate as 0, 1 here. Now to find slope, be careful with doing rise and run because not everything is nice and pretty and going by ones on the grid lines. So go find another coordinate. So I'm going to use this point here at 2, 5. And we're going to use the actual slope formula to find M. So y2 minus y1 over x2 minus x1. So here's x1 and y1. Here's x2 and y2. All right, so plug in your numbers. y2 is a 5, minus y1 is a 1, over x2 is a 2, minus x1, which is 0. And then simplify. 5 minus 1 makes 4, 2 minus 0 makes 2, and 4 over 2 makes 2. So now I have M and I have B, so we're halfway there. So we know it's going to be a Y. We know the M is 2x and the B is a plus 1. We need to figure out the symbol in the middle. So I know that it's shaded below. That's one thing. And it's also a solid line. So in order to shade below, I either need a less than or a less than or equal to. But to make the line solid, I need the less than or equal to. So the symbol here in the middle should be y less than or equal to 2x plus 1, which is the correct inequality for the solution set on the graph. So pause the video, try example number 6. Here's what you should have had for example number 6. Now let's look at writing systems of equations. So this is the same process as earlier, except now we have 2 lines to figure out versus 1 line. And so let's just label. I'm going to label this as the inequality 1, and this will be inequality 2. So let's work on inequality 1. So for inequality 1, your y-intercept is 0, 5. So for inequality 1, b is a 5. Now let's find out the slope for the first one. So m will equal y2 minus y1 over x2 minus x1. So let's see, I already have one coordinate. Let's look for another one. Let's see, another good point looks like this one here. And this coordinate is 6, 2. And so if I do my slope, here's x1 and y1. Here's x2 and y2. So let's see, y2 is a 2 minus y1 is a 5 over x2 is 6 minus 0. So we end up with negative 3 over 6, which simplifies down to negative 1/2 for my slope. And so we need the symbol now. And so for line number 1, it is a dashed line. I'll write it here. It's a dashed line, and it's shaded below the line because it's going this direction. And so for dashed and below, that goes to be, that means that I need the symbol for less than. So we have y less than negative 1/2 x plus 5. That's one inequality. Now we're going to do this process one more time for the second boundary line. So for the second boundary line, we have a y-intercept at 0, negative 1. So b is equal to negative 1. And I need another coordinate for my slope. And we're going to use, let's say this one here. That's pretty close. Negative 2, negative 3. So here's x1 and y1. Here's x2 and y2. So slope will be y2 minus y1 over x2 minus x1. So we've got negative 1 minus a negative 3 over x2, which is 0, minus a negative 2. So this is really a plus. So negative 1 plus 3 is going to be a 2 over, this is also a plus. So 0 plus 2 makes 2, and 2 divided by 2 makes 1. Now for this shaded area, it's shaded above my line, and it's a solid line. So in order to be shaded above and solid, that will be greater than or equal to. So we have y greater than or equal to 1x minus 1. So when you write your answer, you're going to put these two guys together. Y equals negative 1/2 x plus 5. I apologize, it's not an equals. It should be y less than and y greater than or equal to x minus 1. This is your system that goes with the solution set graphed on the grid. So pause the video and try example number 8. And here's what you should have had for your final example.